4.6 lesson is on something called a complex number. This is nothing you guys have seen before, so it'll be a brand new idea, but not too bad once we kind of get the hang of what to look out for. It actually ties in really well with our 4.5 lesson. If we were asked to solve for x, here you can see you've got the x in this parentheses and the squared right there. We'll solve for x here by just using square roots. So we'll subtract the 4 from both sides. So we have 2x minus 1 squared equals a negative 4. Then we would say, okay, let's divide by that 2. And so we have x minus 1 squared equals a negative 2. And then we know we have to undo our squared by square rooting. And here's where we have a problem. We mathematically are asked to come up with the square root of a negative 2. Well, there is no square root of a negative number. You can't take square roots of negative numbers. That's what you guys have learned. So we have to introduce a new idea to kind of get around this idea so we can continue solving for x. So I just want to explain quickly what this is going to look like on a graph. If you remember, we've been talking about, when you solve for x, those are your x-intercepts on a graph. So if we were to graph, this is vertex form. Tricky x, we have a positive 1, positive 4. So we'll run up 1, 2, 3, 4. And then here's our a value. So our pattern of change will be 2 times 1, 3, 5, or a 2, 6, 10 pattern. So up 2 over 1. And here's what our parabola looks like. Well, you can see it's not crossing the x-axis at all. So there are no x-intercepts. That's why, when we tried to solve for x before, we weren't able to. So we're going to solve for x, but we have to bring in this new concept. Nothing you need to write down on this slide, but just wanted to let you know that, it is our wonderful mathematicians that came up with a new number system. They create an expanded system of numbers so that we can work with square roots of negative numbers. Because in our real number set, all the numbers that you guys are aware of, any number that you know of, it is a real number. And so in order to get around taking the square root of a negative number, we have to go away from our real numbers into something called an imaginary number. Again, here, nothing you need to write down, but just be aware, not all quadratic equations have a real number solution. That means that your parabola doesn't cross the x-axis. And we do run into this if you have, here's just an example, x squared equals a negative 1. If you were to square root both sides, you have a square root of a negative number, and we've always learned that we can't do that. There is no real number that we can square and get a negative 1 back as an answer. So nothing that you could plug in for x that would work out here. Alright, so our mathematicians came up with something called an imaginary unit I, or maybe imaginary number I, but I is going to become part of our answers. I squared is equal to a negative 1. But I itself is equal to a square root of a negative 1. So we're going to be able to use this fact to get around taking square roots of negative numbers. The imaginary unit I, there should be a space right there, can be used to write the square root of any negative number. And I'll show you what that looks like in an example. It'll make more sense in a minute. Let me show you just a couple properties of how this works. So if you have, here's two properties we use when we use I. Our first example, square root of a negative 3. Well, we can break this down into, it's a square root of 3 times a square root of a negative 1. Actually, this doesn't really matter, but I'm going to put that square root of a negative 1 in front. So, square root of a negative 1 times the square root of 3. I just broke that down into two square roots. Well, square root of a negative 1 we just learned is equal to I. And then the square root of 3, if we knew the square root of 3, we could simplify it, but we'll just leave it as the square root of 3. So when we have a square root of a negative number, you're going to see that we're going to bring in our I out front like that. And there's the property that gets us from this step to this step. Here's just another property. I'll just work through the example to show you what happens. If you're squaring something, so I times the square root of 3 squared That means multiply it by itself, and then multiply the things that go together. So I times I is I squared. Square root of 3 times the square root of 3 is the square root of 9. And now if we simplify this, we know the square root of 9 is 3, but what does I squared equal again? Well, on that last slide you guys wrote down that I squared equals, it's really sloppy, but equals a negative 1. So we have a negative 1 times 3, or negative 3. So basically just know how to work through these. If you're square rooting a negative number, we bring in I right here. And if you end up with an I squared, we always replace it with a negative 1. Here are just a couple quick examples to show you what this will look like. If you're solving for x squared equals negative 15, we would square root both sides. And so x equals, do you remember how we always had to do the plus or minus when we square rooted things? That still applies. There's still two answers. And then what's the square root of a negative 15? Well, that negative, again, if I were to show all the steps, and we'll start to skip over this, it's the square root of negative 1 times the square root of 15. We know the square root of negative 1 is I, and square root of 15 is just the square root of 15. So x equals plus or minus I square root 15. Can you break down a square root of 15? Do any of your perfect square numbers fit into it? No, so that will be our final answer. On this next one, if we add 7 to both sides, we have 3x squared equals negative 31 plus 7. What is that, a negative 24? Divide both sides by 3, so x squared equals a negative 8. And now as we continue solving, we're to the step where we're going to square root both sides. So x equals, we square rooted, so plus or minus, and then we say, oh, that's a negative in there. So I know it's going to be I square root of a positive 8, and now we can actually work with that positive 8. That does break down into a 4 and a 2. And so we have x equals plus or minus, this square root of 4 is a 2, square root of 2 is 2, and we know that there's an I out front. So just, I'm writing too big for this. What this is going to end up being is plus or minus, and then this I2, let's just write it as a 2I, and then square root of 2. And this will get much, much easier as we practice it. And you'll watch a couple more videos on it also. Alright, now that we know about more than just real numbers, you have your imaginary number I. Now we can talk about something called a complex number. So a complex number is just when your I is involved. So standard form A plus BI, the I term is always second. A and B are real numbers. Here's just an example. 3 plus 4i is a complex number. Now that we know what complex numbers are, then we will be asked to do different operations. Add, subtract, multiply. I don't know that we'll get into dividing. But here's an example where you're taking this complex number, 8 minus I, and we're adding to it this complex number. This is going to feel a lot like combining like terms. You add or subtract the real parts and the imaginary parts separately. So this 8 and 5 seem like they would go together, and they do. That's going to give us 13. And then a negative I plus a 4i is a 3i, so plus 3i. And that's our answer as a complex number. More examples with that. Let me just show you subtraction real quick. Again, just think about it like combining like terms. This negative 2 will go with this 4, so you have negative 2 minus the 4, because of the subtraction will be a negative 6. That is weird when it wants to do that. Negative 6. And then an I minus a 2i is a negative 1i or negative I. So that'll be the answer there. Alright, another operation you'll do, multiplying complex numbers. I'll just show you a couple of these just so you can see what's going to happen. It's going to work a lot like distributing and foiling, so nothing too new, it's just there might be an extra thing for us to deal with. So we'll take this 4i and multiply it by the negative 6, which gives us a negative 24i. And then 4i times I is going to be a 4, and then the I times the I is I squared. Please never, ever, ever, ever leave an I squared in a final answer, because what we have to remember is that I squared equals a negative 1. So what we do is we replace that I squared with a negative 1. So it's really a 4 times a negative 1, which is negative 4. So we have negative 24I minus 4. And then the only other thing to think about is standard form tells us to write the I term last. So this final answer, let's just put that negative 4 out front. Negative 4, and then it's a negative 24I, so minus 24I. Anytime that you are multiplying complex numbers, that I squared is going to show up, so you'll certainly get lots of practice with it. Just look out for it. Don't leave an I squared. We have to remember that equals negative 1, so you substitute in a negative 1 and just keep simplifying. Alright, this last idea is really not too bad at all. It's just we can plot complex numbers. We're used to dealing with our x and y axes in a real coordinate plane with real numbers. This is called a complex plane when we're plotting complex numbers. Your x-axis is now going to be the real axis, so that's going to be the real number, and the y-axis is now the imaginary axis. So just to show you, actually this one, is a mistake right there. So we'll just cross this guy off. But just to show you what this is this point over here. It's a 4 plus 2i, so that 4 is the real number. So on the real axis we'd go over 1, 2, 3, 4. And then 2i, that's the imaginary number, so I would go up 2 on the imaginary axis, and we end up right there. Nothing too tricky, just know that the first number is kind of like the x, and this is kind of like the y for how you're used to plotting numbers. Mathematically, really, this is the real number, and that's the imaginary number. So just to talk about this for another second, I don't know, let's look at this one. How about negative 4 plus 2i? So that negative 4 is the real number, so from the origin, I'm going to go negative 4 on the real axis, and then plus a 2i, that's a positive 2, so I'm going to go up 2, and that's where the point's going to be. That's where that complex number is located. Alright, last slide. Nothing you need to write down, but if you're curious, okay, this seems a little different than stuff we've done. Do people actually really use it? And people really actually do. So here's just some examples of different professions that use complex numbers. If you were to ask anyone involved in these fields, they definitely would be very familiar with I and complex numbers and all this wonderful stuff.